Okay, it's 10 minutes into the time, and we have to start while we wait for others to join us as we continue. So I want to welcome each and every one of us by properly saying good afternoon, everyone, and welcome to the Bincom Dev Center Teacher Knowledge Track Deep Dive Series. My name is Michael Itakuji, and I will be your host for today's session. Thank you all for taking the time to join us. This deep dive series is designed to help us strengthen our technical foundation as C#.NET developers, and also expose us to the future of development, especially with the rise of AI and automation. Today's session is titled "How AI and Automation Are Shaping the Future of .NET Development," and it promises to be an insightful and practical. So we encourage you to stay engaged throughout the session. Please feel free to drop your question in the chat box so we can address them during the question and answer session. We will be taking all the questions when the time is due or when the time is right. So I also want to introduce our speaker today. It is my pleasure to introduce our speaker for today, our team mentor, Mr. Fola Adeniji. He is a highly skilled software engineer with extensive experience in C#.NET development, software architecture, and modern development practices. Mr. Fola Adeniji has trained and mentored many developers and continue to contribute significantly to our growth as a team. Please join me welcome our speaker for today, Mr. Fola Adeniji. Please, sir, you may take the stage now. Thank you, sir.
Thank you very much, Michael, and good morning for those of you in the UK, good afternoon for those of you in Nigeria, and good day to every other person in other parts of the world, depending on where you're viewing from. It's a pleasure to be here. I appreciate this time that Bincom has given me. And again, I personally am all about giving back. So this is a good way for me to also give back. The little that I've learned in all these many years, just to impact the upcoming or younger generations of developers that we have coming on board. And yes, I have been doing software development for about 18 years. I think it's probably safe to say close to 2 decades now, right? And it's funny how I started. I traveled for holiday, and while I was there, I just didn't want to stay idle. So I picked up a book called Sam's Teach Yourself's HTML in 24 Hours. And that was how my programming journey started. So this was not there was no revelation in school. There was no one that had a conversation with me, and that was how I got into it. And incidentally, afterwards, I watched a movie called Hackers by Angelina Jolie. I think by this time I was about 8 or 9 years old. Two significant things happened actually. I got electrocuted, and I saw a movie by Hackers by Angelina Jolie, and that was when I decided I wanted to be a hacker. Well, to be honest, that was when I changed my whole direction, because I was going for economics previously, like my dad, but when that happened, I think something just reset my brain. I guess it was God's will, probably saying this is where I needed to be. So once again, thank you for having me on board. And like Michael said, the topic we'll be sharing is how AI and automation are shaping the future of .NET development. I believe this is being recorded. Is it, Michael?
I think, okay.
It's been recorded.
It is being recorded, right?
Yes.
Okay, all right. So I will go ahead and share my screen. So can you see my screen, please?
Yes, sir. Yes, sir.
All right, let's drag this. So as we move on, I will share some personal stories, talk about a few things, and I will take a bit of time and talk about my journey just so I'm adding more flesh and I'm making it more real. because every time I teach, I like using examples that can resonate with the audience. So it's not just about me, it's not just about .NET, it's not just about AI or the future of AI. It's about my own personal growth journey, how I've navigated the different landscapes I've been, the different parts of the software development lifecycle, and where how my journey has led me to where I am today. So I'll tell you a bit about that, and then I'll mix it as I'm talking about this. So I basically have some slides. We might and might not finish before the intended time. So if we finish, well, then I guess questions can come in early. If we don't finish, then I guess we'll have a timekeeper here of some sorts that will call me to, will let me know once I'm out of time. Again, the subtopic is a complete career roadmap from junior to experienced. So how, for those that are not into software development yet, how do you go down that journey? And how do you become where you see yourself in the next 5, 10, 15, 20, 40 odd years? And so we will be working with an agenda. So once I take this agenda, I'll talk a bit about my story, move on to the next step, talk about how my own journey fits into this. Again, just to try and put flesh on it so it's easier to resonate with what I'm talking about. Right. So the career path is you move from junior, ideally you move from junior to mid-level, then from mid-level to senior, and then from senior you move into staff or principal, as some would call it, a principal engineer, and then you move on to engineering manager, then you move on to CTO. Some move on from CTO to maybe CIO, or maybe even some become CEOs, founders of their own organizations. But not every single person on planet Earth will be a founder, if I want to put it that way, or will succeed at being a founder. Because being a founder takes a lot. That's what I'm saying. So again, manager and then the chief, and then the list, you can slightly go maybe a step or two more higher, or the most of it is becoming a CEO. And then this is SDLC at different levels. SDLC. So a lot of all the talks I'll get, I will at the odd mean, and I'm not trying to insult anybody. This is me just and some might not understand this journey. Some might not even have, maybe they've heard of software development before and they don't know anything about it. So I will go ahead and explain a lot of all these things I'm talking about. So SDLC is software development life cycle. The life cycle, like when you're looking at an automotive industry and you want to build out a car, and the car probably starts off as a chassis. If you imagine a warehouse and the car starts off as a chassis, all the legs of the tire, where the tire goes on the brake pads, and then you have the engine being assembled on it. Then you have the seats. Then you have a different part of the factory making the body of the car. The metal, it's all being welded together, and then it comes on the car. And then you have the other guys or machines, as we know, as with some Tesla factories, or maybe all Tesla factories. I don't know that, so don't take my word for it. But you basically get the wiring of the car done, and then at the end of the day, nothing really goes in. Well, you get raw materials going in, so not nothing. Raw materials going at one end, and it might be a straight journey. For some people, it's a straight line. You go from here to here, but for some, you go here, you go here, you go here, you go here. It's all the development life cycle. It's just the way you will expect a child that was born yesterday to grow up, learn how to walk, learn how to talk, learn how to hold things, learn how to interact with the world, learn how to interact with people, and then grow up to become who they are today. So the same way in software development, we have different life cycles that you have to go through. And then we have a .NET roadmap, and then we have an artificial intelligence and automation. Then we have a multi-language need, and then we have required skills, and then we have projects to build, and then we have question and answer. part of what this multi-language, okay, let's basically break this down a bit. You have the software development life cycle for whatever role you intend to hold. You might be at the beginner level. You might know, okay, let's start from novice, you don't know anything, or you're a beginner, you want to move to mid-level, you want to move to senior, again, following that career path. We have at the top to staff to principal/staff to engineering manager to CTO. You have different software development life cycles at every single point that it will be your core focus as for that role or the position that you think is what everyone is. But I'm a firm believer that AI should be used sparingly when it comes to coding, very sparingly, because even for me that I was using Copilot to work on a Python project this morning, and it was doing certain things that I know are wrong, and I'm like, no, no, don't do that. So basically, with AI, is good for automation. AI can be good for some things, but AI is also not good for some things. We'll watch some of those. Then there's the multi-language need. As a developer, it is advisable you become an expert in one technology, be it C#, PHP, be it Ruby, and then learn one or two other technologies, because that then makes you, I don't know if any one of you, I want to believe you might have heard Mr. Bade talk about global talents, right? Part of what you want to do is you want to make yourself as appealing as possible to an organization. Now, some organizations out there are not just running one programming language. They are running multiple programming languages. So when you have a profile that says you're versed in one and you know a bit about this other one, chances of them hiring you will be slightly higher than someone that has the knowledge of one programming language. So for some organizations, they have a legacy system. Maybe it might be in .NET, and then they have some new systems. They've now moved to a microservice architecture where they now have .NET running. They've split out some of the features they've had. Those things are now big and huge, and they cannot exist in the monolith they had previously. So they split it out into microservices, into Python or whatever language, either Node.js as well. And then you now say, oh, I know .NET. I also know Node.js. They will rather bring you on board than bring in someone that has no knowledge, or maybe just, well, over the person that has just .NET knowledge, or even over the person that has just Node.js knowledge. Now, programming is not just about, sorry, let me rephrase. Software engineering is not all about the programming skills. There are other skills you need to possess to thrive in the environment we're faced with today, especially in the times that we are in today. And then we are looking at certain projects you can build from a newbie, or get yourself ready, good, and then you're building an experienced level. And then we have the question and answer. So I will talk a bit about my journey again. Like I said, I traveled, and then I went to a library to read a book this was in 2014. I went to the library and I read a book called SAM's Teach Yourself HTML in 24 Hours. And fast forward to today, I have done HTML5, I've done CSS3, I've done JavaScript, I've done Node.js, I've played with React, I have done Objective-C, I've done Cake PHP, I've done Xcode to program iOS applications. I am currently doing Python and C#. I have done VB.NET definitely, because that's where I started my journey from. And there are a few other things or hats I've had to wear in the course of my own life cycle, my own journey in the .NET sphere, or as a software developer. So the development track we're looking at right now is backend track, which is .NET, a technical track, a management track, and then a specialized roles, cloud, DevOps, security, and AI. What do we mean by this? Backend track, you're starting out as a developer and you want to learn how to make APIs. I just want to learn about APIs and databases. I just want to learn about how to improving performance of a system. That's all I want to do. Then you have the technical track where, yeah, you can still carry on that line and you're becoming well versed. Maybe you're adding technologies like Angfire even within .NET. You're adding other things in .NET that is helping you improve your .NET skills. And then the management track, as you are doing your bit, as you're becoming good at what you're doing, you now have ownership of projects, and then you have ownerships of teams where you have to manage the team and help them grow, help them succeed, see where critical issues might occur in the future, and you're putting steps to mitigate it now. That's the management track. Now you can choose not to go down that track and just go, I just want to be more like an individual contributor, where all just give me the work, points me, or it's like don't let me use that analogy. I will not use that one. It's almost like you're saying, point me in the direction you need something done, and I'll get that done. Right. I'm not necessarily willing to carry anybody along. I think some organizations these days have realized the importance of individual contributors. They will get the job done, right? But they don't necessarily play too well in a team, and they definitely do not want to manage a team. So that's where you have the management track. And then you then have the specialized roles, which is cloud computing. You're not deploying things into a server somewhere, but a server you manage, you're deploying it into a cloud infrastructure. And then you have DevOps, where you're setting up CI/CD, that's continuous integration, continuous deployment, to push things from your machine. And then you have like a repository, a central repository, either you're using Azure. How did I forget that? Either using Azure as your repository, or you're using GitHub, or you're using Bitbucket, or there are a few others out there, but GitHub being one of the recognized ones. Now, besides all this, you're also talking about the security of the systems you're building. So let's say I'm building a system that does attendance monitoring, and I'm deploying that attendance monitoring into the cloud on AWS. One of the key things I want to ensure is that on AWS, the S3 bucket that I'm potentially using to store the images of the people, of the staff, of the users of that system, is it an open bucket? Can anyone go in there and see the contents of that bucket, or is it restricted? And then my database, can any IP address hit that database, or am I putting it in a VPC, a virtual private cloud network, where only certain IPs can access that database? And then am I locking that database, and am I using encryption at rest? So you can basically start talking about a lot of other things, right? And technically this is outside the .NET sphere, but then these are things that if you can get well-rounded in it will help your career path and make you more appealing. Again, I also link this tech a bit to global talents. It helps you to be a more globally appealing candidate in anywhere you are, or any organization, or any country. So we will move on to junior backend developers. So let's talk a bit about me again. When I started, like I said, HTML, CSS, JavaScript, I remember doing a lot of coding, like 50 lines of code to just see a page green, and then maybe you see one line across it, saying welcome to Folarin's page. This is HTML, by the way. And it was all well and good, and it made sense. And I did more HTML, CSS, JavaScript. I played with Dreamweaver when Dreamweaver came out. I actually used Dreamweaver for some developments. Then I moved from HTML, CSS, JavaScript to VB.NET. VBA, Visual Basic in Applications. And that's where I used things like, I think it's a Microsoft Access, where I wrote .NET code at the back end of Microsoft Access, and I was using that as also the database, and I was doing all that. It was going all well till I then realized that, oh my goodness, there's something called VB6. By the way, I didn't learn VB6 until I was in my final year in uni, because I had a project I was delivering in Access and VBA, and my laptop crashed like a month to go before submission. And then someone actually, I met, there was someone I knew, well, I wouldn't say we were friends back then, but we've not kept in touch. I would say one of my classmates was kind enough to show me VB6, and because I had a background of VBA, I was able to get VB6 and get the work done and submit my project in time before the deadline. So VBA, after VBA, VB6. After VB6, I moved into VB.NET. After VB.NET, I played in VB.NET space for a while. While I was in the VB.NET space, I played with PHP. I didn't even touch Python then. I didn't touch any other I didn't touch any JavaScript frameworks. I did definitely core JavaScript. So, and I did Ajax, I did jQuery. So you can see my career path from not knowing anything, knowing a bit about HTML, CSS. Basically, that's how the web works, and everything all condenses into HTML, CSS, and JavaScript, right? And then I went into Visual Basic Application, where I was building Windows applications for my final year project. Then from Windows applications, VBA, I moved to VB6, again, still doing Windows-based applications, right? Little connectivity with, connecting multiple systems. So one standalone system was what I was building. Then I moved to VB.NET. Then I started seeing what was possible in the realms of Visual Basic, seeing what was possible in that realm, started expanding my reach, expanding what I could do, expanding how many pieces I could control. Then you're talking about having a network, and then you're having a main server, then sub-servers that are feeding off that network. And then from there, I moved into PHP. Then that was when I think when I moved into PHP was when I was in VB.NET. So I was more talking web applications now. I started moving. I think I actually left desktop applications altogether, and I just stayed in the world of web applications. But for that one, I was acting as a full stack developer, which you'll see shortly, which was the front end and the back end. So having said that, now let's talk about what will be expected of your journey as your junior developer. Now, please note that this doesn't necessarily factor in that you're a novice, you don't have any knowledge whatsoever, and you're coming on board, and then all you're just saying is, oh my goodness, as a junior backend dev, these are some of the things you need to know, which is one, .NET CRUD APIs. I don't know if anyone knows what CRUD is. Again, I won't make an assumption. I will say it. CRUD is creates, updates, and deletes. So those are basic applications. So you have an application that manages how many phones I have in my house, and I can say, I have 5 phones in the house right now. I'm going to create a system that saves those 5 phones in there with information that I can easily update, and I can delete the one phone I'm not using anymore, or keep track of a library management system where you want to see who took possession of a book in the library, when did they take it, when is the deadline, and all those things just keep on increasing. All right, let me put it this way. The complexity of that system can increase as you build and grow. And just let me say this at this point. It is important that for every system you are attempting to build, there is an acronym called KISS. Keep it short and simple, right? As much as possible, start off building your system as a simple system. As the complexity increases, you can increase the complexity of your systems, but then the way you should ideally, it's advisable you increase the complexity of that one system you're building is to have multiple simple systems, because you could potentially have multiple. Okay, I have like a set of cards here, and I can have, just give me a minute. I have a set of cards here. I can have cards, right? And you could layer them together. Each on its own is just one simple system. This is another simple system. But by the time you interconnect a lot of all the systems together, you realize that you then have a complex system. But then remember, the complex system is made up of one singular simple system, where it's easy to manipulate system. So by the time in my own case, I started. Can you guys see Michael? Can anyone hear me?
Yes, sir. We can still see your screen, sir. Yeah, I can hear you, sir.
I think, but there is a network issue.
All right, fantastic. Thank you.
Yes, just that the network is breaking a bit, but I can see
your voice is breaking.
Cool. And use sorry. Okay, I guess not. So I want to use that .NET code to add a record into an in-memory management system. I don't want to save it in a database. I just want this to be saved in memory, because it's like let's take a calculator, for instance, right? You're saying you want a calculator that can do simple arithmetic operations. Add subtract, division, and multiplications. We all know that those 4 operations, add, subtraction, division, and multiplication, they can be summarized into 2 operations, right? So you are either multiplying or adding, right? And then you could basically then say, right, I also want to remember the last numbers I added. So again, I want to save whatever calculations I've just done. I need to save it in memory. It's not going into a database. The system doesn't require a database. It's a simple system, quote and unquote. Well, I was going to say it's probably stateless, but not stateless because you're remembering things. Sorry, by the way, stateless systems are systems that they don't need to remember anything. Basically, give me the parameters, I'll calculate the results and give it back to you. But then there are some stateful systems, they need to know what happened the last time. Based on that, they can then act on some new information you'll give. GitHub is essentially pushed from local systems into there, and they are managed in there. And then there are Git operations that you also need to know and familiarize yourselves with, which is about GitHub pull, GitHub push. You do have pull requests, you have merge, and then you have things like rebase. When they are ideally, GitHub would automatically. Let me dial back a bit. GitHub is a central repository system where, imagine all of us on this call are working off a project and we are working on one file. Because we're working on one file, it is easy for Git to have those changes and allows you so that our work in we all can take a copy of that one file, work on it to that one singular file. This cannot automatically handle those merge requests, right? Which is where to come have to use, or has done, move on with what this person has done. He's not going into details about every single thing that is required. It would be nice if we could do that 2 hours, right? 10 minutes. Well, it's almost half for now, even at that. Where we potentially should be looking as plan at, okay, this is what you need, this is what you do, this is how you plug this.
Mr. Fall, I think the voice is
I
still
think
breaking.
so. If you want to know more, this is your first
we couldn't
connection.
hear you properly.
Yes, sir. Your network is kind of breaking, sir. We hardly hear everything, sir.
Can or can't? No. Hello?
Yes, sir. The network is having issue. Like the network from your end is having issue, sir. We can hardly hear everything, sir. Kind of breaking, sir.
Unfortunately, I'm in Nigeria right now, so this is in a way to be expected. Can you hear me now?
Okay, sir. Yes, sir. Continue, sir.
Yes.
Okay. Yes, so I apologize. I'm generally based in the UK, but right now I'm back home in Nigeria. So apologies for the network. It's generally good. It works when it works and it doesn't work when it doesn't work. So right. So basic SQL and Git, and then you have unit testing. So remember when I was talking about the examples of having simple units, simple systems that become complex system. The whole intention of that is when you have a simple system, it's easy to write a test for simple systems. It's easy to write a test for 5 simple systems, 10 simple systems. However many simple systems you have, they become testable units. So for every time you are writing your code or learning how to write or learning about software development as a general rule of thumb, every single thing you do should be in simple parts that can be easily tested. Because part of how you're ensuring the quality of the work you're delivering is that you have a testable code. let me sound this as it's not a note of warning, neither is a caution. If you are just starting in the C# track or software development journey, I'm tempted to say you can almost ignore this rule because you just want to know something is working, right? And the thrill of it working at times beats I know for me, when I was learning, I didn't care about any rules and regulation and LA guidelines. I just wanted it to work. And it worked. And it was much later I started learning that you need to start putting structure into your code. Now, the earlier you can learn that you add structure into your coding, the better it will be for you as a developer, right? But if you're starting off and you don't have structure just yet, I'm tempted to say don't worry so much about it just yet because it's all a learning curve. I love playthrough learning, right? I write code, I break code. That's the whole purpose of being a software engineer. You write and break code, but the most important thing is that what have you taken from that thing that you just learned? Right. So if your own route is, I want to just learn, I'm going to ignore all the structures, that's a good place to be. If your own path is, I want to learn the basics and all the guidelines and start writing production ready code from day one, by all means, it's whatever rocks our boats because everyone behaves differently. Everyone has different learning styles. So, and then you then have C#, and then you have LINQ, and then you have Entity Framework Core, and then you have REST. So these are all part of the things that we need to learn. And then you have AI code suggestions. Now, this part, I was adamant about adding these bits, but what we have in today's day and age in some places, in some organizations, is junior developers are beginning to write code using AI tools. And I've had multiple friends that have told me that the code that the junior developers have written with AI tools, they've spent a lot more time debugging and fixing those codes as against someone that wrote it from scratch. Which is why originally when I started this talk, I was like, writing code using AI tool is not bad. It's good practice. But my own is you need to know what's the whole purpose of why am I doing what I'm doing? Why am I doing what I'm doing? That's crucial for your journey. Now, that's why you're doing what you're doing might actually not come at this level, which is the junior developer level. A junior developer is like a soldier, like a major or a general or a lieutenant is telling you go there and execute that maneuver. And he's just saying, sir, yes, sir. And he goes off and he does it. Right? At this point, you don't necessarily understand you're not looking at the whole system you're working on or the organization holistically, meaning from top to the bottom. You probably don't even have that view of seeing from the top down. All you know is that I've joined an organization, I'm excited, they want me to work on this system they've done, I'm happy to work on it, and you just go for it. That is not a bad place to be. It's a route, it's a development life cycle. There are certain things you need to know, right? And at that stage, you don't need all that information. Right. Then I mentioned full stack. Before I do that, I was going to jump. Okay, let's not jump. And then, so what we just talked about is a junior back-end developer. Again, junior being the key word. Right, you're not expected to know too much, and most times it is fine to stay on one programming language because, again, yeah, you're even still learning that language, you're not well versed in it just yet. You're making mistakes, you're making syntax errors, you're learning syntax, you're making mistakes, you're learning about how to do certain things. What are the rules of engagement in this organization I'm with? So those are the things you're learning. Now, there are some times you join an organization and the expectation of you will be to be a full stack developer. If you were to work in established industries, they have segregated the paths. Some of them don't even have full stack developers. What they have is either back-end or front-end developers, right? You go off and do your front-end things, you go off and do your back-end things, and then let's make it all talk together and work together. There was a company I worked for. I worked for Andela for 5 years. I was in Andela for 5 years as a senior technical consultant. And there was a company I worked for, and they needed me to be backend engineer there. Now, because they were doing backend and they were doing Blazor frontend and Angular JS, which I know both of them, There was a time I was stuck and we needed a front-end engineer to do something. All the front-end engineers were really busy with other work. So I told I told the CTO, then you know what, I'm happy to take this thing on. I don't mind. Again, that's what I do as an engineer. And I was like, I do appreciate what you said, but no. We have a breakdown, we have a decoupling of things for a reason. And so he did not give me the permission to go ahead and tackle the front-end part of the work. Now, in a startup, you will most likely be expected to be full stack engineer. So again, you need to look at, you working for a startup, a mid-sized organization, or an enterprise organization. Those generally inform how you want to work. Because of job stability these days, I might not necessarily say the best flow to go about is startup, mid-level, and enterprise. Some people finish school, or some people get into software development, and before you know it, they are right in enterprise organizations. Some get up and some have done 10 years, 20 years like me, and they're working for startups. So there is no right path, right route to go when it comes to choosing an organization to work with. I think ultimately what you need to look at is, what do you want to learn? If you were to join a company like Google, right? Google is a big organization, like we all know. You need to ask yourself, am I learning what I need to learn to be able to move up the ladder in my journey? Am I working on products that are very insignificant in Google, that to make a mark in Google, you need to make a mighty splash in a mighty ocean? Someone put it to me this way: do you want to be a small fish in a big ocean, or a big fish in a small ocean? But most importantly, I don't even think that should even be your drive. Your drive should be, what do I need to be learning at this stage in my career? And am I getting the best of it right now? Even if you're working for Google and you realize that you're working on projects that the visibility of that project is low, and you don't feel like you're learning enough, what are you doing on the side? What are you doing on your own? Are you following a guideline that's what we have right now to shape what you're learning, to shape your career path? I always advise people, I mentor to people at work as well, and I've said to them that the organization you work for has an expectation of you as an engineer, as a developer, as a staff of the organization. They have an expectation of you. Do you have an expectation of the organization you're working for? Do you have an expectation for yourself, a growth path for yourself? How do I move from here to here? Do you know the things you don't know? There are 4 stages of learning, and I should be penalized for this because I always forget the 4th one. And I've used this example way too often that I've not learned the 4th one. So apologies for that. After this, I will learn the 4th one. The first stage of learning is, I don't know what I don't know. Like, as a newbie into software development, you don't even know what you don't know. The second stage is, now I know what I don't know. Because you've spoken to people, you've attended conferences, you've attended talks like this or trainings like this, and you realize, right. That's a missing piece. That's a missing piece. That's a missing piece. This mighty ocean is a missing piece. Then there is now, I know what I don't know. You've now taken intentional steps to ensure you know what you don't know. There's a 4th one, if I'm not mistaken, I think it's the subconscious. Like, for those of us that drive here, when you're driving to the store to pick up something, or you're going to a friend's house, at times you're not necessarily thinking of that driving journey. You drive into a car, it's an automatic, you put your car in automatic, you're just moving and stopping, signaling, moving and stopping, signaling, moving and stopping, and you get where you're going without putting effort into it, because it's become it's part of your subconscious now. You can do that thing subconsciously. So full stack is one of the roles most times, like I said, in startups. Some mid-level and enterprise level probably would require this, but for most enterprise level organizations, they already have the clear demarcation between the roles. Then you have the authentication flows. This is where you're saying, right, you're moving, because now you're the one handling the back end and the front end. You need to work out how the flow happens, right? So when I send this username and password to that API, I get that back. Okay, where do I store that information I'm getting back, so that the front end is able to see it and know that this user is authenticated and they can flow. So the flow of everything now becomes, again, maybe not necessarily your priority alone. you need to work with someone a bit senior than you in this role to be able to determine the authentication flow. Then now, because you're working on the two separate systems, front end and back end, are you doing CI/CD for the front end, CI/CD for the back end, CI/CD for the whole lot? And how are you breaking that down? Do you have two different repos for the two different projects? Or do you have one major repo that has the sub repos and these projects are in? Those are questions you now need to start asking yourself. Again, a lot of all this also then depends on the organization you're working with. What I would advise at this point, not every organization we all will work for will be using what you call best practice. Part of what you don't know is you might not even know what is considered best practice. Again, it is fine not to know. It is not fine to dwell in what you don't know. Research. What do I need to move my organization forward from where we are into 21st century? What are the steps we need to embody? What are the steps we need to implement to be able to get us to be the new 21st century IT industry or law industry or logistic industry, whatever industry you find yourself working with? You want to find out the best practice you can put in place to ensure that you're setting your company up for greater success. And then one of the other key things you need to look at, which we'll probably get there, is this best practice I want to do, is it going to cost us money? But again, remember, the expectation at this point is that you are no longer a junior developer. You've kind of moved to around mid-level. Even some of the things I'm saying is not necessarily for mid-level developers. Some of these guys, these ones are handled on senior engineers level, or team lead level, or staff engineer, or principal engineer level. Or some organizations, the CTO would have a roadmap and have planned everything, and everyone is just implementing. But for a proper, well-structured organization, the CTO will have his own vision for the organization. The CEO will have a vision, CIO will have a vision, CTO will have a vision, and then as a developer, either as junior, mid-level, senior, or staff, or team lead, you will have your own vision as how you want to all implement the level ops vision for the organization. So CI/CD we've spoken about, and then you have, again, UI generation. There is a project we're working on right now in Bincom where I'm mentoring, and someone did bring up a conversation of using Lovable as a tool for UI generation. Again, I'm not against AI tools, but I'm against when you don't even know what the AI tool is doing. You can tell me you drive a car. It's fine to drive a car. You've driven the car for 1 or 2 years. Fine. You don't understand how the internal workings of the car works. That's fine. But when you say you've driven a car for 5 to 10 years, my expectation of you is that you should be able to open the bonnet and look at any little things that might be wrong with the car. Because if you own the car, you've driven the car multiple times, you probably know what is wrong with the car, where the car has certain issues and what you can do to fix those issues. So those are the things I would advise, an in-depth knowledge of how it works first before even bringing AI tools in to generate anything for you. Then you have things like this, integration specialists. So some organizations say, I'm going to skip this one actually. Let's skip this one till the last, if that's fine by everyone. So you've moved from junior developer, right? And you've done backend where you've learned your basic create, updates, deletes APIs. You have your methods. You're using REST. You have your basic SQL that talks to your database. You're saving data in there. You're fetching data in, and now you have all your repository, all your code base in the central repository. So should your laptop crash today, you're safe because you can basically go into GitHub, authenticate, pull, and you pull all your code back. Again, what I would advise, let me sound the notes of warning here. It is important that you commit your code as frequent as possible. Better still, when your task has been broken down, or when you're breaking down your task, break it down to the smallest unit as possible, so that when you are done with a unit of code, maybe in under 2 hours, you can push that code in and save it into GitHub, because anything can happen to your code any single time. And I'm testifying because there are numerous times I've written code for like 3-4 days and I did not commit my code and my PC crashed or my PC restarted. Most times it's crashed again. This was back when there were a lot of Windows blue screen of death back then. So that was what we had back then. So you've moved on now from junior dev, you're talking about full stack. and then you're talking about a mid-level. Now, for mid-level, your responsibilities, so for some organizations, it's mid-level, for some is senior level. But so this is as you're transitioning, but this is what you want to have at the back of your mind. You're not talking system ownership. You're taking full responsibility for the design, performance, reliability, and life cycle of a system, right? So we have the library management system we spoke about earlier on. You're owning it, you're looking at the design, you're looking at how can I improve the system, you're talking about quality leadership, driving engineering excellence through best practices, testing discipline, and a culture of continuous improvement. You're looking at the system, you're looking at what did we do well yesterday, what can we do well today. You're putting all those things into considerations as you're building the system. You're looking at solid, right? There are solid principles that govern software architecture. You're looking at it, you're now taking your code base, you're scrutinizing the code you've written, right? Is my code following this pattern? Is my code following that pattern? Is my code following that pattern? Can I substitute things in my code? How am I introducing dependencies into my code? Those are not the things you're not talking about at this level. And then you're looking at domain-driven design, you're looking at microservices. The one system we spoke about where I said you have a system working in .NET, but you've realized that because this system was built as a monolith, the payment feature is always crashing because now we have 500,000 users. And when 500,000 users are trying to do a subscription at one time, the system crashes because it cannot handle the system. You can either decide to increase the load of the server, the specification of the server it's on, or you could further break down your system into a monolith, into microservices, and then you now redesign your payment system such that it's able to handle a million requests without crashing. You're now thinking of redundancy, like now that I want to make 1 million requests to the service, how do I ensure the requests are not dropping, the requests are not failing if this server goes down? They are thinking of things like caching. So it begins to expand. Your knowledge ideally now starts getting expanded from the little you started with as a junior dev to ownerships, to scrutinizing code, to rewriting code, to refactoring your code base so that its ability is able and capable to do a lot more. And then now you're talking microservices. You're talking clean architecture, modular again. Remember, again, I'm coming back to this. Keep it simple. Whatever you're doing, keep it simple. Even with microservices is all about making different services as part of one major system. And those services only do one thing. And those things are, again, that is all about keeping it simple. And then by the time you go into microservices, you now have, it's almost like for every time you go up in your software development journey, there's always going to be a challenge that you realize that needs to be faced. As good as microservices is, one of the things you need to worry about is source of truth. What system are we using as a source of truth? How are we passing information from one system to another system? What if there's a failure in passing information from this system to this system? How do we ensure it's reading the live prices? Because you don't want a system, you don't want to build a system with microservices where your prices of your products are not getting updated and then you are selling at a loss. How will you then go back to your customers and be like, sorry, that product you bought for, in context, I'll use Naira. The product, because I'm in Nigeria, the product you bought for 15 Naira, sorry, there was actually a mistake, it's for 15 Naira. You're going to lose trust. So there's a lot more at stake now. And then this is where we look at this. This is where you're now talking about the skills you need to be able to be successful in this organization, in this industry, in your software developer journey. There are certain skills you need to own from your junior level right up onto senior level. And this is where, for a senior engineer, this is where they should be able to look at the system and see the gotchas. They should see the pitfalls that you might encounter later on and then address it now so that it doesn't become a problem later. Because a lot of all the engineering challenges I've encountered, they have cost organizations money. As I know some of you are aware, AWS crashed about 2 times last month. Well, one of the regions crashed about 2 times last month. It definitely cost AWS money. Cloudflare crashed very recently. It definitely cost Cloudflare money. All those things cost people, if not the organization, their users, because they would have had service level agreements with these organizations. So, And then you're talking about containers. Sorry. You're talking about containers where you have either Docker, you have Kubernetes, and then you're saying, right, I used to deploy into one server before, but now I want to start using Docker. I want to containerize my applications so I can use this for this for that for that. Put them into different containers. I don't have to install Postgres anymore on that server because I can basically spin off a Postgres image in my container. You now have to start having those talks. But again, this is part of, do you know what you don't know? If you're looking at a mid-level senior engineer, these are some of the things you need to start considering now. If you're there in that journey, in your journey right now, these are some of the things you need to start doing. And then you have the platform, sorry, the staff / principal / the solutions architect, where they are looking at, they're not necessarily even looking at code at this point. They're looking at the systems as black boxes. What's the output of that system? What's that output is going as input in this system? How does this system authenticate with that system? Is that sufficient to do something? How do they, okay, now we have 20 different systems. How do they all authenticate to each other? If you're talking microservices, okay, how are we introducing this to this system? And then you have to be careful because you have what you call latency. The time it takes to get to send out a request for something and get it back. If in some systems it might take you 1 second or a fraction of a second, in some systems it might take you 50 minutes or 10 milliseconds. In software engineering world, milliseconds is a lifetime. And they are talking about critical decisions, right? We need to migrate this, or rather, this our DB right now. SQL Server is not working for us anymore. Sorry, just give me 1 minute. Just give me a minute. All right, apologies for that. I had to quickly attend to something. So right, then you have critical decisions. So you have a MySQL database running. And MySQL database at some point, the costing for that is just skyrocketing. Your data in there is, we are running into terabytes, and you're like, this thing is not sustainable. We can't keep doing this. Let's move part of our data to cold storage because we don't need that data every single time. And then let's use MariaDB or Aurora because it's 50 times faster than SQL Server. So those are the kind of decisions that the staff / principal / architect have to make. And then they are saying event-driven or cloud native. Especially with event-driven, you are saying rather than us, because it's costing us resources every time we are if you have chats or a chat system, right, where you have like web.io open and it's listening, you have those listeners open, right? Those things are like practically always active. But then you have event-driven architecture where you are sending an event to a subscriber or you're publishing an event, and then only those that are subscribed to that event take action. Now, if you're publishing an event that I've added it, let's look at a shopping cart, for instance. If a user adds a basket to a shopping cart, you're publishing an event that an event has added to the cart. The inverse generation doesn't have to listen. It listens to that event, but it doesn't do anything because I don't care about invoicing until payment has been made. Right now, the user is just adding things to the shopping carts. Right? I don't have to be involved in that process. And that way you've built a system that is resilient. You built a system that is listening to when it should act as against when it's listening all the time. In short, the systems now, I'm subscribing to Netflix. If a movie doesn't come on Netflix, I'm not going to watch it. The movie can come on YouTube, can go on Prime. I don't care. As long as it's not Netflix, I don't have to watch it. So you have now made your system more robust and so smart that it now knows what to watch out for and what not to watch out for, and is only acting based on set of instructions it has been given. And then this is now crucial. By the time it's crucial at every stage, don't get me wrong, but by the time, excuse me, by the time you're not talking microservices, observability becomes crucial, because now you have multiple parts of one system in little chunks spread around globally on multiple servers, multiple systems, possibly running on Docker. And you want to measure that it's still working fine. You want to measure when there's an issue. Because when you had your monolith application as a junior developer, when things break, the whole application breaks, you know. Right. But in a microservice organization, when your SMTP stops working, for instance, you won't know. When your invoice generation system stops working, you might not know if you don't have something like observability in place. Now, as a junior developer, you will not be tasked with observability. Let me rephrase. You should not be tasked with observability, again, because every organization have their own working dynamics. You might join as a junior, you might be expected to do it. You can't, I don't think, you can say no, but again, if you're choosing to go with an organization, then you have to play by their rules and regulations. As long as you're not being asked to break something, you need to be able to at least do something about that. My motto is that an engineer is a problem solver. What problem are you trying to solve in your own rights? Are you constantly evading challenges? Or for every challenge that comes your way, you're stepping up and being, you know what, I'm going to have a go at you. Now, most times, sometimes the staff or the principal or the solutions architect are also tech leads. And they are the ones that they are mentoring because they realize that this person has potential. Either this junior has potential or this mid-level senior has potential and wants to move up the ladder. So you know what? Part of my time will be to mentor these people and help them get to the next stage they want to be in their own life cycle, in the software life cycle. And like I said, part of it is they are looking at what you currently are, what you currently can do. They are looking at what we have now against what we need to be in 5 years' time. They are looking at resources we have now against the resources needed for 5 years' time. Are we able to grow those resources in-house? Are we able to move people up the ladder to get there in 5 years? Or do we have to look externally to hire these people in? So, which is why I said some people rather do individual contributor. Please let me just write the code. I don't want any other thing. I just want to stick to code writing, do code writing, live and breathe code, and not have to manage people. But should you want to manage people, this is a career path for you to consider. So if you're looking at, right, I'm here now, I don't know anything, but in 5 to 10 years' time, I would like to be able to lead people, then there are certain skills that come with the job you need to know. Some of those skills come naturally to some people, but for some people, it doesn't come naturally. We'll look at some of those skills as well later. So AI, code health, and analytics, using AI to instantly analyze code qualities, detect issues, and improve overall software health. So yes, so part of what you're also doing as a tech lead now, remember you've left junior, you are no longer a mid-level to senior level where you're taking ownerships. Now you're going a step higher. You're looking at, right, let's start looking at the quality of the codes that we are churning out on a daily basis. There's something called SonarQube. I don't know if anyone of you has heard about SonarQube. SonarQube helps with checking code quality and some other things and detecting issues. Or even you can give it the coding, I think it's called links, a coding pattern that you use and saying that if any of the code that is being written doesn't follow this pattern, either camel case or whatever it might be, I need you to flag that code and fail. That can be built in SonarQube as an example. There might be others out there, but I've used SonarQube in the past. I don't really know about any other one. So let's stop for a minute and almost do a summary of what we've spoken about. From someone that doesn't know anything about software engineering, that wants to go into software engineering, you're now doing software engineering, and then you started off as a junior backend engineer, so you don't have that much responsibility on you. But potentially, remember, immediately after looking at the junior backend engineer, we considered full stack. You might be a full stack engineer in whatever organization you're working with, especially if it's a startup. Right. So you then have to handle the backend work where you're talking about .NET CRUD applications. You're talking about some basic SQL statements. You're talking about knowing Gits. You're talking about let's actually consider that. Talking about unit testing, C#, LINQ, Entity Framework Core, REST, right? And then if you're then talking full stack, you're talking React, Angular, authentication flow, continuous integration, continuous deployment, UI generation with AI tools. And then you're talking, that's for the junior. And by the time you're moving into senior engineer, you're now doing more of system ownership, quality leadership, solid domain DDD. It's called DDD. There's also TDD, test-driven development, and microservices and containers. And then once you leave, well, you technically don't leave any of this first because you've won that at a particular point in time, you can go back and function in that capacity. Right. So it's not that once you stop being a junior, you cannot be called on to come and do CRUD or play CRUD APIs again. No. It just means you've gained capacity to do that thing. You've increased your capacity, but you've not forgotten where you've come from. Let me rephrase. You shouldn't forget where you came from, because you should be able to go back and do that job if no one is there to do it and it needs to be done. And then we spoke about the software principal or architect, solutions architect, where they're talking about the platform design, critical decisions, event-driven, and observability. And then we spoke about team leads. Are we still with me so far? Before I progress?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Fantastic. So now let's move on to engineering manager. This is again, organizations are structured differently. There are some organizations you join as an engineering manager, you won't write a line of code. So if you are like me, that you think you code till the end of the world, right? Engineering manager might not be for you, or it can be for you, but you're not living coding. You still take on coding by the side. Right, where you're talking about, you're looking as an engineering manager, you're looking at the resources, and I'm saying resources on purpose, the resources you manage. You're looking at how are we delivering, how are we hitting our deadlines, are we doing this delivery, are the deliveries on time? If those deliveries are on time, if we pushed 5 things to live last week, how many of those things came back with issues that we had to fix again? So your own focus is different. Now you're talking about, that's why I said resources, because then you're going to work closely with human resources, HR departments, that, right, we've looked at where we need to be as an organization. We've looked at the goals of the organization and the roadmap the organization has put forth to us by the CEO or CIO or marketing or sales. Now, our response to that is we need 2 new developers. So because you should know the kind of skill sets required, then you are involved with hiring. Then you're also involved with performance. Like I said, remember, you might have been doing this already before you hold the title engineering manager, but if you almost disregard the titles, but look at the different phases and the journeys and the responsibility, some that are expected of you and some you are expected to do. If you're hiring, it's only fair you're doing performance reviews, right? So I've hired you, I've given you your KPIs, key performance indexes. You need to have done XYZ, XYZ, XYZ. Have you met those KPIs? If you've not met with those KPIs, how can we help you succeed in this thing you're doing? And one super, super, super important one, stakeholder communication. How are you pacifying sales team that, don't worry, this thing will be ready in 2 weeks? Pacifying marketing team, this thing will be ready in 4 months. Pacifying CEO that this thing will be ready. Pacifying CFO. CFO will say, we are paying, money is going out, we are paying salaries, but we can't see the effects of it. There is no traction in engineering. So these are the kind of meetings you now have to start setting. So some of your responsibility for this role might be meetings. And your meeting, again, depends on the organization you work for. You might be meeting with multiple stakeholders. And before you realize it, your week is gone with meetings. Which is why I said for some organizations, engineering managers don't write code. Some organizations, engineering managers do write code. I think if you join Facebook, you are probably even expected to know basics. of programming, even as an engineering manager. I don't know if they actually write code, but because I was looking at engineering manager roles at some point at Facebook, part of it requires you to know some rudiments of software engineering. More than some rudiments of software engineering, actually. Because if you're going to be managing an engineer, I don't need Michael to come and tell me this task will take 10 days. Right. But whereas, because I was a developer, I know ideally this task should take 3 days. So if I didn't know software engineering and the life cycle in that aspect, I won't even know Michael was making up some days, or Michael was adding some. Sorry, Michael, I'm using that example. I'm not showing you what that was. This is just trying to make it so we can all resonate.
There's no problem, sir.
Yeah. So we are seeing Michael, we are seeing the task Michael is saying as a dev. Having once been a dev, I'm like, but Michael, you know that this thing can take 3 days. Okay, you know what? Put 4 days, 1 extra day for anything that can happen. Contingency plan. Right. And then I'm talking to Michael, I'm negotiating with Michael. Okay, finally, we agree on 5 days. The rest of the stakeholders are happy, engineering is happy, we have a win. So the software development lifecycle, requirements, design, development, tests, deploy, monitor it, maintenance. This has slightly changed. Well, depends on the methodology you're trying to go about achieving all this. Because once you get your requirements and you do your design and you do your developments and you do your tests and you do your deployments, if feedback at this deployment stage is not positive, you're going to go back into developments. And that's where you have your, what you call agile methodologies, where you have a unit of work. Build, get me different cards, but you break down the work into smaller cards, right? Such that once this work is completed, you git push, you save it, CI/CD kicks in, deploys those changes into your development environment. The client sees it, or your UAT or your testers or your business analysts test that bit of work and they sign it off when it's done. They sign that one off when it's done. They sign everything off when it's done. And while you're signing off, you're also presenting it to the users or external stakeholders that are testers or that need to test, or beta testers, where they are also signing off every stage of your development process. Should any of your stages fail, it will move from deployments into developments. And that's why it's agile. You're pushing small units of work at every single point in time, such that users can interact with those small units of work and give you a thumbs up or a thumbs down, saying, yes, you've captured our requirements right, or you do not capture the requirements right. One thing worth mentioning in my roughly 20 years of experience in software development, this is one of the most crucial parts of a system: gathering what the user wants. Some organizations use business analysts to capture these requirements, and then it only comes to us at design phase. I'm of the opinion that ideally, I think developers or at least team leads needs to be at this stage, requirement stage, where once the client is saying, I want this, I want a man to be able to wear a rocket pack and go to Mars and come back in 2 hours. The technical leads are saying, with the capacity of what we have right now, this is not possible. The technical lead is saying, you know what, this is not possible for us as an engineering institution right now. We are not able to send, scientifically, it's not even possible for us to send a human being to Mars and back in 2 hours. You know, so you already have those pushbacks from that level, at that level, in those meetings, in this meeting, such that your expectations now for the rest of engineering team are not unfounded, are not unreasonable. As long as this goes smooth, then you can almost be sure that the rest of the engineering process will go on smooth, because you have captured what the client wants. Then the engineers or the architects that need to do any design are then looked at, okay, what do we need to do? What cloud infrastructure do we push it in? What is the requirements? What authentication do we need? What kind of database do we need? How many users do they need to interact with the system? In the long run, in the short term and later on, how can we scale up this system? Is it built to scale? How can we do X? How can we do Y? and then you now enter development. So all this planning. So for a junior dev, most likely you are starting at this stage. You might actually know and see all this, but you might not be really involved in this tool until this stage. And then as you move on into mid-level senior, you're in this stage. And as the higher you go, the part of the full development life cycle you now become a part of. So there's now a few more things. You, as a beginner, you are not starting the requirements gathering. You will be given the requirements to read, so you know what you're doing, and build features, basic tests, like we said, Git, and the manual testing. These are some of the things you'll be required to do as you start off your journey. Then you have the mid-level senior, where you've read the requirements. You're like, right, I know we need login feature, we need user management, we need authentication, we need this. You're breaking down the task, the user stories, right? And then the tasks are further now broken down. You are at this point even doing system design. Do we put into AWS? Do we use GCP, which is Google Cloud Platform, or do we use Azure from Microsoft? How do we set up CI/CD going forward as well in that system? And then you have the advanced, where you're talking architecture review. We've kind of covered this a bit, so I'm breezing through-ish. Architectural review, threat modeling. This system we're working, is it finance? Oh, if it's finance, okay. How are we mitigating against fraud? You cannot build a finance system and not worry about fraud. Yeah, you will be setting yourself up for failure. You know, how do we combat fraud? How do we ensure these cards are, if we offer cards as a product to our customers, how are we sure that the cards are not being used across multiple geographical zones within hours of, within minutes? Well, we know it's meant to be here and it's here. How do we handle roaming? Or sorry, how do we handle when the customer travel? There are a lot of things that now come into play depending on the complexity of the system that you will be building at the end of the day. You're talking scalability, observability, and AI ops. There are a lot more things that go in. It's not just DevOps. They are talking ML ops, machine learning. You're talking AI ops now. There are lots of ops that are coming up now with the advent of new things happening in the tech space. So we are looked at, this is a bit more breakdown in what you need to know, beginner, mid-level / senior, and then advanced. And then, yeah. So we have spoken about this, but yeah, let me just talk it. This now goes into a bit more details. C# object-oriented programming, that's OOP. Async methods, like you're making a call to get something. Am I waiting for the call? Should I be waiting for the call? Or should I say, right, Michael, could you please get me that pen? Do I need the pen to work? If I don't need the pen to work, that means I can literally send Michael to get me a pen while I go off talking to Buvana. So that means I've made an async call. I'm not waiting for the response. When it comes, I've delegated who will handle that call, and I'm talking to Buvana and I'm talking to Olabisi to ask them to do other things while Michael is still coming back with the pen. It's not keeping me back. There are some things that as you're designing the system, it needs to wait for the call, that response, because I need that pen to be able to write instructions to give to Buvana, for instance. Or no, I don't need the pen. I need to do something else other than that. Link is all about querying the database and setting structures in .NET. Entity core, Entity Framework Core, SQL, Git, clean architecture, JWT. This is more with authentication. A compact secure token format for transmitting authenticated user information between systems. And then you have Docker, you have Redis, you have in-memory. Is all about in-memory. There are different ones. And then you have Azure Basics or AWS or GCP. Again, remember, this is depending on the cloud infrastructure in use for the organization you are working with. If it's your own, you can sign up for AWS or GCP or Azure. They all have a free tier plan where you can play with systems. For AWS, do this founder credits where they give you, I think, $1,000 for $1,000 worth of credit, not $1,000 cash, where you can play with the systems for I think 1 or 2 years, and they all have very they all have variants of what they do actually. The three major players, and I guess some of the other lesser players have something different too, something similar. Apologies. So we have this microservices, DDD, there's TDD, there's event sourcing, Kafka, Azure, Service Bus, Kubernetes, cloud architecture. And now we come to, I guess, one important part of this, which is all what can we then do with AI? A lot of all the things we've said, AI can't do it. I'm not going to deny that. A lot of all the basic things we've said, from beginner to senior level to advanced level, AI can take context. If you give it a full context, I run an advertising firm and we have a new client with this requirement that needs this XYZ. You're giving it context, or you're basically setting up the right prompts for your AI to generate things for you, and you're giving it to this. AI can't do that, but I would advise against using AI blindly and copying everything verbatim. Oh, AI giving this, I'll just copy this and chuck it in. One of the core things I will advise is, for any system you're working on, ask the question, why am I working on that system? For every time, there was a company I worked for when I was Andela. I worked for one of Andela's clients. One of the things we advise to do is that when the BAs come up with, oh, we need this feature, ask the BAs, why do we need this feature? At this level, so I was senior here, ask them, why do you need this feature? Because at times, historically speaking, for other organizations, we've built out a feature only to find that when we looked at the usage of some of these things, we built it, it went live, and it never got used. That is not the best use of company resources, because I'm a company resource at the end of the day, right? If we're building systems that nobody would use, it's not efficient, because there are other things that some other person can be working talking boilerplate. That means you understand the system enough to know. So you're talking mid-level, senior level, where you're saying, right, I need this pattern, this structure to be in by default. So for that reason, I'm going to do this template. So once I run this one singular line of code, it generates this template for me, and I can just plug the missing bits. You can use it for tests, right? Because your code has been written, you can then say, right, I need you to write tests to check and ensure code correctness, prevents regression, and promotes reliable releases. Even at that, AI can still get it wrong. Don't get me wrong. So even after you write your test, you have to use your test cases. So you have to be quite intentional with the prompting you are giving AI to write your tests, as against blindly saying, here is a .NET product, generate all the tests for it. I want to have 70% test coverage, generate 70% test coverage for me. That can be disastrous. API clients, rebuilt models that simplify calling external services by handling request responses and authentication. So a lot of all those multiple requests you're making, maybe from 2 different controllers, 4 different controllers, streamline it into one central controller. That is the one place that all calls are going out of the system and all errors are being centrally logged. You know, infrastructure as code, explain legacy code. So you've been tasked to come and work on a system. It was done in C++. Now you're meant to move it to C#, port it to C#. How do I do this conveniently? You can use AI to say, right, AI, looking at this bit of code, this function, what does it do? And then you have the infrastructure as code templates, where you have things like Pulumi, you have things like Azure, ARM templates in Azure, you have code formation in AWS, and I don't know what it is in GCP, Google Cloud Platforms. But yeah. Now, AI cannot replace business logic. The business logic that says if there are 5 people, make the price 5 naira. If there are 6 people, make the price 10 naira. If they are greater than 5, less than 6, because there's a child involved, then you have to make this thing. So there are a lot of things that AI, as of now, in my opinion, please note, it's in my opinion, it is not a worldwide opinion, even though some people share my opinion. AI cannot replace business logic, cannot replace architecture, cannot replace security, and cannot replace stakeholder communication. You still need to be the one to initiate it. That being said, it can simplify some of the processes, but these ones, they still has to be proper. It has to be a well thought out plan of how you want to go ahead to implement it. Now, you can now give AI some bits to implement. AI then becomes like a virtual assistant where I know I need to do 10 things or 20 things, and I start off one and I get it up to 50% of task one. And I say, right, AI, here you go, finish this off and let me see. So I'll review that and determine if I want to bring it into my code base or discard it. And then now we have AI tools. You have .NET plus AI tool, which is Copilot. So now Visual Studio Code has Copilot built into it. I believe there is, it might not be in Visual Studio itself, which is my Microsoft's own .2 IDE. There is code in there as well. Then there's Azure OpenAI, there's Semantic Kernel, there's OpenTelemetry plus AI. There are a lot more AI tools out there. You know, there is ChatGPT. There are so many of them. It's now choosing the one that works best for you. I have heard it being said that Copilot seems to be a lot more better for writing code. That is not a rule. You can use what you want. Ultimately, deliverables is what we are gunning for. Accurate deliverables is what we are gunning for. And then this is now a crucial part. This is now a crucial part where it's saying, why more languages? So in all this, the expectation is we are still talking C#. Is C# we've been talking C#. We live and breathe C#. But it's important we know another language. Like I said, the use case I gave before was, you know C#, you join an organization that have their code in .NET, but they've started to go into microservices where they've ported a singular feature from their monolith database into Python or Node.js or React, or PHP. Your chances of getting into the organization could be dependent on how many programming languages you know. Like for me, like I said, I started with HTML, even though some will not consider it a programming language. HTML, Visual Basic Fabrication, VB6, VB.NET, C#, Xcode, Objective-C, PHP, KickPHP, even though that's a variant of PHP. I do Python now. I have learned Node.js as well. So you can see the multiple things, even though I'm not actively working in projects for all of them at the same time. But right now, I'm actively working on C# code base and Python code base. So there's almost always two different languages I'm using at any given point in time, and two different projects I'm working on. And then besides languages, you need SQL, NoSQL, database interactions. This is JavaScript and TypeScript, by the way. So these are more front-end technologies. This is back-end technologies, right? And then you have SQL Server. So you have a database you're talking to. Where is your database? Is it relational database? Is it non-relational database? And then DevOps basics, more like how do I set up a simple CI/CD, continuous integration, continuous deployment, so that once I push into GitHub, again, Git has to be part of your flow. Once I push into Git, it auto deploys into my server, wherever I want to host my server in. Then now we are talking about beginner projects, like I said. Beginner project could be crude applications. Again, something simple just to see how it works. Then you're talking authentication systems. You're talking blog. You're putting an entry in. You're pushing data in. You're seeing the data, and then you're talking Hangfire, a .NET library for running background specs, jobs, queues without needing a separate Windows service. You know, if you were like what we are working on currently, I think I don't know. Buvana, is it Hangfire you guys are using for the .NET projects? For the queuing,
No.
a shed like .NET's. I think you're using an inbuilt service in .NET, right?
No, I'm not sure whether we are using, but based on my understanding, we are not using that on Fire.
Okay. So I believe there's a library in use. I think it's Q something, a schedule. I can't remember now. But yeah, so that's what is being used. But again, Hangfire can be used. So for a beginner project, you can just do something simple. API first, don't authenticate, don't put authentication, just push and pull. Push data into database. You're pulling data, even not database, in-memory database. Don't do external database yet, right? Then once you are done with this, software as a service backend, right? So again, remember, sorry, so this could be on your local system. Software as a service now, you're deploying it into the cloud. You're talking warehouse management. You're talking now with warehouse management. One of the things you have to consider is logistics. If you're talking warehouse, when we run out of things, how do we contact the suppliers or the vendors? How do we get those things in? How do we track the delivery? How do we track what has come in against what you ordered? What, more like what I ordered versus what I got. How do we put things in place? So you're getting bigger, you're expanding yourself, you're building your capacity. Then you're talking microservices. What does a microservice entail? What does it do? How do I ensure there is the data I need in one service is true, is the real data and it's not outdated data? How do we handle that? Best practices. Then how do I build a payment system? These are advice. This is just advice. It's not you must do this to be better, become what you need to be. No. It's just that this will test your capacity that you've built. These projects will test out those capacities. Then now advanced project distributed systems. You're talking IoT telemetry, Internet of Things. You have multiple devices plugged in multiple places. Maybe you want to build something for a fire station. You buy IoT devices, you plug it in multiple buildings. You're constantly reading the building of the heat levels of the building. You're tracking number of people going out and coming in. So in the event there's a fire, you know that 10 people were in the building, 5 people came out. So that means technically 5 more people are stuck in the building. So you want to know that. And recommenders, you're talking Netflix. How Netflix, you watch a movie to recommend another movie for you because you saw Lord of the Rings. Here's another one to watch. Logistics tracking. Again, you could probably look at maybe talking about building an Uber of some sorts. How does Uber work? And then retrieval augmented generation. This is what I'm currently doing I'm doing something similar for where I work now using Python. So again, those are just examples of projects you need to be working on. You need to task yourself. You need to build capacity. And the only way to build capacity is go all out. Go all out. Go all out. Then you have the hard skills. You have your .NET 8, 9. I think .NET 10 is out now. C# 14. Azure microservices, DevOps, SQL, AI enablement. These are things you need to know to even succeed at all as a junior developer. Maybe not microservices. Maybe not DevOps. Right? But .NET, Azure, you need to know some of these basics. And then these ones are now crucial for you to be able to succeed in all the levels, either as a junior dev, either as mid-senior level, either as a advanced senior staff, principal, solutions architect. Communication, problem framing, documentation, and collaboration. There's no point writing all that code if you're not documenting it for someone else to read and understand what you've done. If you were to pick up a project and it doesn't have documentation, you know how you would struggle with it. Well, thanks to the advent of AI, you could basically say, can you read this kind of code and tell me what it's doing? And AI will try its best to give you that. But ideally, documentation is one of the is not one of the most loved parts for all developers. Some developers don't love it. I don't necessarily love documentation, I won't lie, but it has to be done, and I do get it done. And I'll leave this on screen for a minute. Roadmap to becoming an ASP.NET Core developer. So let's just look at this and take it in. I didn't come up with this, by the way. This wasn't my own drawing, so it wasn't my own illustration of things. In all these things we've said, I didn't mention some things. Some I just forgot because that's how it is, right? You forget a few things, but it's important you almost learn what you don't know. Again, the 4 stages of consciousness is important. We look at the 4 stages of consciousness. Maybe before we close, I'll have a look at that just to see. Final thoughts. Again, whatever you're working on, as a junior, mid-level, senior, advanced, whatever, understand what you're trying to solve, right? And then you have to make some judgment calls. What do I use AI for? What don't I use AI for? And then system design, you're looking at the system holistically. How does what needs to go into box A for there to be an output from box A that feeds into input of box B, that the output of box B feeds into box C. That's how do I layer all that and how do they all work together? And then AI-driven productivity. In as much as I am not against AI, like I said, AI can improve your life as a developer greatly if you understand how to use it. Rather than just giving AI something blind and asking to generate code, you have to almost structure, because you have a better understanding of the system you're trying to build. And you know that when you're building a system, certain things should come before certain things. Again, you need to understand how .NET works, especially when it comes to authentication. I think one of the authentication comes before authorization. I seem to forget how it goes now. If it's the other way around, everything will fail. And I've generated AI code that basically put it the other way around, and it did not realize what it had done wrong in .NET when your program.cs. So you can easily go down a rabbit hole with AI if you're not careful. So don't give it code, don't ask it to do things blindly without first understanding what it's meant to do. So, and thank you very much. So kind of finished before 2 hours. Like I said, we might, but this is where I want you to please take a minute to digest all we've said. If you want me to go to a particular slide, I'm happy to do that. And then I'm happy to take on questions. Any questions? Any .NET related questions, please. Thank you. Over to you, Michael.
Okay, sir. Okay, sir. Thank you so much for the time and the explanation and everything. I have, within myself, I've achieved a lot from this very lesson. But the part that I'll see wants to get a clear understanding about. First, I think I have two places that I want you to still revisit, please, since we still have a few more minutes to go. First is for the beginner aspect, because I can still find myself around that place, so I will I'll still need more explanation about that, because you were talking about the beginner and the full stack. Now, to some extent, I understand the explanation of a full stack in the sense that you need to work on the front and the back end at the same time to make you a full stack. But in your explanation earlier, I want to get a clear understanding between these two people, because you were talking about being a beginner for back end, and maybe you do say something about some organization preferring, or I really want to get that explanation again. Like when we talk about full stack and back end alone, is there any greater differences? Like, is there any preferences when it comes to employment, when it comes to organization picking? Because you do explain that some organizations do have their separate back end and their separate front end, where everybody goes to their own work, then bring everything they have together. Then the project manager go over it, check what they need to do or what is acceptable. Then they merge everything, and the organization push it.
I see that, Michael.
And all of that. So, and after explaining that, which I get it clearly, this still audible, sir?
Yeah,
Am I still audible, sir?
Yes, please go on.
Okay, sir. Okay, sir. So I want to get this clear understanding. Is it that I myself, because I am I'm a back end developer, a beginner for that matter anyway. I want to understand, is there something I'm missing for not being a full stack, or do I need to be a full stack to gain employment or to be recognized higher and all of that, sir?
Let me put it this way. As you've heard, no knowledge is wasted, right? I think it's important that for your software developer journey, you need to have aspirations of the kind of organizations you want to work for, right? Are you with me, Michael?
Yes, sir.
Now, once you have one or two or three organizations in your purview that you want to work for these guys, look at their internal structure. How are they working? How do they work? What do you need to do? Do they have a clear-cut demarcation? Are they so structured that you need a clear-cut, that there's a clear-cut demarcation between back-end and front-end, or they actually have mixed, meaning if you're a full-stack engineer, you have your chances of entering the organization are a lot more higher. I won't necessarily say you are missing or not missing. As a backend engineer right now, what we said in all these things, you have to become a stack developer. If you've not mastered the backend developer, I won't even advise it. Not that you shouldn't look at it or look into it or learn one or two things, but to say I want to, or again, who knows at once and learn one thing at once. Some people are that good nowadays that they can learn multiple things at once. I'm sorry, I'm not in that category. I'm old school. So I rather stick to one thing, learn that thing, and move on. Right. But you can basically decide to be good in your .NET backend. While you're doing that, you're learning Razor. Technically, it's still C# syntax you're using and HTML. You're learning Razor or Blazor. And at a point, you now pivot from Razor, Blazor into React or Angular. Now, will it make you more employable, or will it increase your chances of being employable or your employability rating if you're a full stack developer? Yes, because any organization will see you as an asset, that you know the back end and you know the front end. Now, imagine you know back end and front end, you know C# back end, you know React front end. You go to an organization that they're using PHP. Is it serving you? No. So in that organization right now, your skill set almost becomes useless. But then remember, in programming, there are a lot of... So if you're asking, should you learn, should you be a full stack engineer? If you don't have the eye for UI, being a front end, a full stack might not be the best advice, because you will just be realizing you're learning something and you are not being at it, whereas you could learn what you are being good at and become good at it. So in short, where strengths lie, where your strength lies should determine where you want to be in, or your passion lies. Again, I know some people say don't follow your passion, but as a developer, you need to know where you're stronger. Where am I strongest? Where am I stronger, back end or front end? And if you are good in both, by all means, please learn full stack. I don't know if that answers your question.
Yeah, yes, sir. Yes, sir. Yes, sir. I get that, sir. Thank you so much. So with this, I understand that.
One other thing I want to add to that, sorry for cutting you short, is you need to be kind to yourself when you're setting goals for yourself. Right? If you're saying I want to learn full stack development in 1 week, don't get it done in 1 week and you lose morale. You might realize that you might not even get anything done in 1 month. But whereas if it's against you saying you want to learn something in 1 week, if you're saying I want to learn back-end development for 2 weeks and I want to learn front-end development for 2 weeks, you give yourself 1 month. It is more time, but it is better you I'm Yoruba. One of the things to say in my language is that whatever is good takes time. Right? Whatever you want, whatever is good takes time. So why not just take that time out to spend time to learn what you're good at and learn something else? There is no hard and fast road to these things, to be honest. But the one thing that it's been said that it takes 10,000 hours to master something. So if you're saying you want to be an expert, for those that I've mentored, I've taught in the past and currently, I tell them, if you're saying you want to learn something and it's been said it takes 10,000 hours to master one thing, and if you're only given 1 hour a day to software development, that means you're only spending 1 hour a day. If you need to spend 10 hours, if it's 1 hour a day, that means you need 10,000 days. If you're saying, right, I do software development for 5 hours a week, 5 hours a week in a month, you're talking about 20 hours. right? 20 hours in a month, in a year, you're talking 240 hours. You're still looking at over 5 years. But if you're saying I do software development 10 hours a day, 10 hours a day puts you at, and maybe I don't do it on weekends, puts you at 60 hours by the end of the week. 240 by the end of a month, depending on, some months have 5, but let's just do 240. And at the end of a year, well, you do the maths, right? But you can see that the longer you put, if the more you lend yourself to something, the more of that thing you know. The more you invest your time and effort in something, the more of that thing you will know. So if you're investing your time in backend development, you will know backend development. Front-end, you will know front-end development. There might be challenges. There might be challenges and hurdles you have to overcome. There are months that I've said, there are weeks I've said, no, this thing is not working for me. I'm pulling my hair out. Even now as a senior developer, supposed senior developer, there are days I've gone through this Python code and it's not working for me. And then there are days you just get that eureka moment. Oh, I see what I'm missing. So that's why I said you need to be kind to yourself as you're learning. So, and then you're giving yourself SMART goals, measurable goals, and not just some goals blindly that you need to do.
Sorry, sir. Thank you so very much, sir. I get everything you explained now. Okay, I know some other people might still have questions, so let me be fast with mine because we are already running with time already. So, sir, my second question is okay, let me say I'll ask these two questions together so that you just attend to both of them and I won't need to take separate time anymore. Now, first, you do talk about AI, because if we look at our topic for today, it's basically how to, how AI can come in and all of that. So you do mention the advantage and the disadvantage in the sense that you said you need to know what you give to AI for AI to give to you what you need to, right? Now, I want you to please throw a little bit, or should I say, a bit of light to that. Sorry, like what you're trying to explain here that I really want to get is there, or my question, let me put it this way, so it will be a question now. Is it that there is a particular way we are supposed to ask AI a question to give us the answer we deserve, or do you? I still want to get that. Like, is there a way we can present, or we are supposed to present the question to AI, being ChatGPT or any of this, that will give us what we need exactly? Or what do you say about that, sir? Then my second question, which is the last one, as you are going to attend to the both, sir, thank you so much, is that now in this whole thing that you just teach us now, like the whole thing now that you explain, now another way or another thing I want you to also touch is that, is there a way, like is there a particular pattern, or is there a particular should I say it, level that we need to come to understand what we'll be expecting in an interview or something? Like, for example, let's say I have an interview as a beginner. Is there a way I should prepare, or do I just need to know these basic things? I know this very event is not about interview questions and all of that, but it's just my own personal question that I want to get to understand something. Is it that if I have an interview as a beginner, C#, let's say for a back end, is there a particular way I could prepare, or a particular, out of all you just explained, are there some things I need to pick up to, like, dwell mostly on it before going for the interview? Although this is outside the topic of today, but it's just my own personal question. I'm sorry. Thank you, sir.
That's fine. Yeah, thank you for the questions, Michael. So I'll take it from the top up. It's almost like, as they say with computers, it's garbage in, garbage out. Right? If you put rubbish in, it will give you rubbish out. And this is what I tell people, that artificial intelligence is like water. Right? Water would flow and fill anywhere you put it in. Now, if you want to use AI responsibly, you have to give it a container. Give it a container and tell it that the container you are filling right now is a cup. Sorry, this is not a cup, but I'll please visualize a cup. This container you're filling is a cup. Now, based on the constraints of this cup and the requirements of this cup, now do X, Y, Z. Now, it will try its very best to assume certain parameters for that cup. So based on that, it now helps you and gives you a more befitting answer. There's actually something called prompt engineering. I don't know if you've heard of that before, Michael.
No, sir. No, sir.
So there's something called prompt engineering. Just trying to look up the definition right now. So it's a process of designing and refining prompts to get best possible outputs from AI models like ChatGPT or anything. So you almost start off with a context. So if I come to you right now, Mike, and I say, I want to buy a car. You don't know why I want to buy a car, right? And then you're probably like, well, do you really need a car? You know, you don't need a car. You know what? Maybe you should save your money and do something. Or maybe buy investment or buy shares. But if I come to you and I said, I live in a particular city, my family stays in another city. For whatever reasons, we are apart and I need to travel a lot. And me spending money on public transportation is not making sense. It's more expensive or in the long run. So I'm looking to buy a car so that at least that money I'm giving Uber, if I fuel the car, I can make those journeys and I can easily go at least 12 minutes and I can still drive all the way home. I've given you a bit of context. Now you understand my reasoning a lot better, why I want to buy a car. It's the same way with AI. And I'm an IT. I run an IT organization, and we are looking at building bespoke systems for our users, where our users are schools that have special needs. Right? We are looking to design a system that will XYZ or XYZ. So you be development, software development in the special needs area, right? And then you're not asking it your question. So that way, it's almost, that's prompt engineering. It has narrowed down what AI is this wide, so I don't go out of screen. AI is that wide. You want to narrow down what is meant to do to something like this, so that when you now ask your question, you are hopefully going to get a good answer that is fit for your purpose or your whatever solution you're trying to build. That is one. And then about what to learn for interviews. You again, there are platforms out there that let you do coding practice coding questions, right? So I will believe you need to start off looking at the organization you want to hire. Now, I have never been, I don't know, people do it. I'm not against it, but I've never been I'm just going to apply to 500 million companies. Every job application I've gone at times, I've looked at, at least this is the industry I want to work in. I love to work in this industry. For that reason, I'm going to target roles in this industry. If I'm targeting roles in this industry, I'm going to look at the top players in that industry. What are their criteria for hiring? Notice top players, right? Now, based on the top players, what do I need to know to be successful for these top players? Even though maybe I'm looking at first for, even though it's number 50, I'm looking at applying to, but I'm setting myself up for success. So I've done my research to know what they are looking for in candidates, incoming candidates, junior, senior, mid-level, whatever. I'm looking for what they are requiring, what they are expecting me to know, and I'm going to ensure I know what is expected of me before I step into that interview. I hope that has answered both your questions.
It's all right. Thank you so much.
Okay. Is it me or can you guys hear me now? Can you hear me okay?
Yes.
Okay. So
Okay.
there's
And
another.
sorry, I do have a question about well, I put it in the chat. So
Yeah, I was
basically
going
it's
to read
about
that. Yeah, do you want to read out your question then, Jade? I hope
okay.
that's the right pronunciation.
Yes.
Okay. So please go ahead.
Basically, yeah, that in the chat, that's all I want to. I'm just kind of curious about, cause my job. I mean, we deal as an IT consultant, we deal with a lot of legacy system. So, but I haven't tried using the AI to kind of to explain the legacy code. So I'm just wondering I mean, how far, I mean, how accurate that can be. And of course, I know that, legacy system has so many different codes, and some legacy system is even as old as AS400 and VBA and things. I don't know if the AI is kind of capable of doing that, handling those kind of system right now.
You'll be surprised what AI is capable of. What I would do is take you back a bit, and you need to look at are you allowed to expose your code base to AI? You want to have that question answered first, Jade.
Oh, actually, that depends on the client. So some client is okay with it, some client is kind of really careful about that. But I'm just kind of sometime the client doesn't even know this kind of possibility exists. So you have to kind of propose that as a kind of a potential, solution or potential, method to them, and then they can determine whether they want to do it or not. Yeah.
Okay. So off the top of my head, even though I'm gunning for a solution without knowing a lot of all the parameters, I might say if you work for an organization, your organization might want to build your own LLM, right? And it's hosted in-house, right? No connection to the internet. It's all offline, right? And then you can feed it this code. So in a safe space, so you probably then want to add it to your SLAs to your clients to be like, right, there is a possibility that we'll share your code base with our in-house offline LLMs to help us understand your code better. And then once they approve, as they're onboarding, you might not need it if they have documentation. But if you're dealing with things like AS400 and VBA, you want to be able to run this by your LLM. Can you explain this piece of code to me? And while it's explaining the piece of code to you, you don't also want to be in breach of any contracts. And I guess that's more for me, the crucial part, that the explanation of the code is you don't want to be in breach of anything. Like you rightly said, though, if your clients don't even know what is possible, then I guess you might be safe, but you still want to check documentation protects you and the organization from doing this. Or better still, if you were to build your own local LLM that has no online capabilities, then you could safely give this to the LLM and tell it to explain the code for you. And yes, you'll be surprised what AI can do these days.
Wow. Okay. Yeah. Thank you. It's just that, sometimes sometimes in a company or system, you're facing so many legacy code that nobody's know what it's doing anymore or how it was done before. So yeah. So I'm just thinking that this is a possibility, of course. That's something that we can try. We can look into. Yeah.
Definitely. And in this case, AI might be able to rewrite the code for you in a more modern language, but you first want to understand how it's working, right? You need to understand what restraints there are in. And even if you want to regenerate the code in AI, it's someone that has, let's say you want to do it as C#. You still need a C# engineer to sit and look at the code when it's generated. Because you don't want it to just randomly generate it, and there might be edge cases that the C# code won't catch, but whereas the legacy code catches every potential edge case scenarios. But if you write your C# code, you might just say, oh yeah, I'm just going to skip this part. I don't need this. It's outdated anyway. You need to that's why I said a proper understanding of the environment of the sector or the organization or the client you're working with is important before you start plugging AI to do anything for you.
Yes, exactly. Thank you.
You're welcome. Over to you, Michael.
Okay, sir. Thank you so much. We have, the time has really gone off already, and we, with how much we have enjoyed the section and the event entirely, if you permit us, we'll keep on coming with question and question and question, because I hope it won't be long, and we'll still have you here again to open our eyes to these things and how they are all done and all of that. So I want to sincerely thank you. And I know the rest of us might still have something to say, but I'm sorry, I apologize on behalf of Beacom entirely that the time is already up and won't be able to take much question again. So with this, as we come to the end of today's deep dive series session, I want to sincerely thank everyone for attending. And a big thank you to our speaker, Mr. Fola Adeniji, for the valuable insights shared today. We encourage all team members to continue exploring the C# knowledge track, apply what you have learned, and try to grow more. And I want to also still appreciate our speaker. You have done so much. Thank you so much, and God bless you. So with this, I would like to, as a co-host, I would like to bring the meeting to end now. Thank you so much, everyone. My name is Michael Itakoji, your co-host for today, and I wish you a wonderful rest of the day. Thank you, sir.
Thank you. Thank you, everyone. Have a lovely weekend.